Hello students, welcome back to your channel Chemistry Simplified. Today we are going to deal with a very essential chapter of class 12 chemistry, that is biomolecules. Okay, biomolecules. What are these biomolecules? I'm sure you know the answer, right? And they are a very essential part of our living, right? So how do we define biomolecules? What are biomolecules? Biomolecules. Where is my marker? Alright, what are biomolecules? So to define biomolecules, these are the organic molecules that are essential for the structure, function and regulation of all the living organisms. Some of the biomolecules that we are going to discuss are carbohydrates, proteins, nucleic acids, etc. Okay, so let's get started with our chapter today. So first question is, what are carbohydrates? Carbohydrates. When we were kids, we had only one answer. The energy giving foods are known as carbohydrates. But now the definition has changed. What are these? Basically, these carbohydrates, they are produced by the plants, right? And some of them very naturally occurring, these carbohydrates are glucose, sugar, starch, etc., right? And most of them, they have a general formula that is C6H2O. Most of them, they fit into this formula and they are considered as the hydrates of carbon. For example, glucose, that is C6H12O6. But there are some compounds which, even though they fit into this formula, but are not carbohydrates. For example, we have acetic acid, that is C2H2O2. It fits into the formula, but it is not a carbohydrate. Likewise, we have raffinose, C6H12O5, which is a carbohydrate, but that does not fit into this formula. Okay, so we cannot say that carbohydrates are the hydrates of carbon. Okay, rather it will be more prominent to say that carbohydrates are the optically active polyhydroxy aldehydes or ketones, or some of the compounds which can give some unit on hydrolysis. So it is more good to say that carbohydrates are optically active, the polyhydroxy aldehydes or ketones. Okay. Now there are different ways by which we can classify this carbohydrate. For example, they can be classified as monosaccharides, oligosaccharides and polysaccharides. Now monosaccharides, what do we understand by mono? Mono means a single unit. Okay, so two carbohydrates which cannot be further hydrolyzed to simpler units are known as monosaccharides. And most of the naturally occurring monosaccharides are glucose, fructose, ribose, etc. etc. Okay. Then what is oligosaccharides? So those carbohydrates which yield 2 to 10 units on hydrolysis are known as oligosaccharides. They can further be classified as disaccharides, trisaccharides, tetrasaccharides and so on. For example, one such is sucrose. Sucrose on hydrolysis give one mole of each glucose as well as fructose. And then we have polysaccharides. Poly means many, saccharide is water. So, carbohydrates that yield large number of smaller units on hydrolysis are known as polysaccharides. For example, we have starch, glycogen, gum, etc. And these polysaccharides, they are not sweet in taste, and that is why they are also called as non-sugar. Okay, so if you want, you can take a quick screenshot. Meanwhile, I have a sip of water. Alright, so I hope this is clear. Now, another basis of classification of carbohydrate is on the basis of reducing and non-reducing sugar. So, what is a reducing sugar? Reducing and non-reducing sugar. So basically, reducing sugar are those carbohydrates, those which can give a positive test for the reduction of, or which can reduce Tollens reagent as well as Fehling solution. They are said to be reducing sugar, and those which cannot, they are known as non-reducing sugar. Okay, so they can also be classified as reducing and non-reducing. Okay, this is the way we can classify carbohydrates. Next, very important, we are going to discuss with the monosaccharide. Now, what is a monosaccharide? Let us discuss what is a monosaccharide. Okay. Alright, so one of the most important monosaccharides that we are going to discuss is glucose. Glucose is naturally occurring, also it is found in grapefruit with the molecular formula C6H12O6. And how it is prepared? So, preparation of glucose. Glucose can be prepared by different methods. One such is by hydrolysis of sucrose, and another by the commercial method by hydrolysis of starch. So, the first method is from sugar, or we can write it as sucrose. On hydrolysis of sucrose in the presence of dilute HCl or H2SO4 in alcoholic solution, it gives one molecule each of glucose and fructose. Okay. Second is from sucrose. That is the commercial method. And 393 Kelvin under pressure to give N molecules of glucose. Okay, so these are two methods by which we can prepare glucose. And okay, next we are going to discuss, next topic is very important, that is structure of glucose. Now, do you know structure of glucose? the structure of glucose is like this. This is the structure of glucose. It is also known as aldohexose or dextrose. But what is the evidence of this structure? What is the evidence of this structure? So let us see. Let us find out what is the evidences that show that the structure of glucose looks like this. Okay, or it has hydroxy group. Why it is known as aldohexose? Okay, so let us start. The structure of glucose. Please keep taking notes if you need. Evidences. First is that the molecular formula was found to be this C6H12O6. Okay. The second evidence is that on prolonged heating of glucose with HI, it gives N-hexane. It gives N-hexane. That is CHO, CHOH, whole 4, CH2OH. In the presence of HI, it gives N-hexane. Which shows that the carbon present in glucose, they are all arranged in a straight chain. Okay. Then the second one is that on treating glucose with hydroxylamine and hydrogen cyanide, it gives an oxime and cyanohydrin, which confirms the presence of a carbonyl group. Okay, for example, it is an oxime and if it is treated with hydrogen cyanide, it gives a cyanohydrin, which you might have learned the formation of cyanohydrin and oxime in the chapter aldehyde. Okay, so this is a cyanohydrin which confirms the presence of a carbonyl group in the structure of glucose. You can quickly take a screenshot meanwhile. Then the next one is, if we treat the glucose with a mild oxidizing agent, that is bromine water, it gives us a gluconic acid, thus confirming the presence of the carbonyl group, that is aldehyde group. Likewise, if we treat it, I'll show it here only. Okay, so if we treat it with bromine water, if we treat it with a mild oxidizing agent, that is bromine water, it gives us a gluconic acid which confirms the presence of a carbonyl group, that is aldehyde. Okay. Likewise, if we treat the glucose with acetic anhydride, then it will form glucose pentaacetate, thus confirming the presence of 5-hydroxyl group in the structure. Okay, so if you treat it with acetic anhydride, it will give glucose pentaacetate. Glucose pentaacetate, okay, that confirms the presence of 5-OH group. Alright, then the last one is if you treat it with a strong oxidizing agent. I'll do this side. If you treat with strong oxidizing agent like nitric acid, it is going to form succaric acid. That is succaric acid, which confirms the presence of primary hydroxyl group. Okay, so these are the evidences that are in the favor of the structure of glucose. Okay, so let us recap what we have learned so far. First one, we have learned the classification of carbohydrates. What is the classification of carbohydrates? On the basis of sugar unit, carbohydrates can be classified as monosaccharides, oligosaccharides and polysaccharides. What are monosaccharides? Monosaccharides are those carbohydrates which cannot be further hydrolyzed to give simpler units like glucose, fructose, ribose, etc. Secondly, the oligosaccharides which can yield 2 to 10 units like sucrose. When they get hydrolyzed, it forms one molecule of glucose as well as fructose. Then we have polysaccharides which can yield large number of units on hydrolysis. They are not sweet in taste, and that is why they are also known as non-sugars. Then the next classification on the basis of reducing sugar or non-reducing sugar. So basically the carbohydrates which give the positive test for reducing of tolerance reagent test or Fehling solution, they are considered as reducing sugar. If they do not give the positive test, then they are known as non-reducing. Okay. Then most important monosaccharide that we have discussed here is glucose. What is glucose? Glucose is having the molecular formula C6H12O6, which is a naturally occurring carbohydrate, sweet in taste. Okay. Now it can be prepared by the hydrolysis of sucrose as well as starch to give each molecule of glucose. Then the structure of glucose. Okay, the evidences that give the in the favor of structure of glucose. First is if we do prolonged heating of glucose in the presence of HI, it forms N-hexane, which gives the evidence that all the carbons are arranged in a straight line. Secondly, if we treat glucose with hydroxylamine and hydrogen cyanide, it forms an oxime and cyanohydrin, thus confirming the presence of a carbonyl group. Third, if we treat the glucose with a mild oxidizing agent like bromine water, it will give gluconic acid, okay, which confirms that the carbonyl group which is present is an aldehydic group. Then if we treat glucose with acetic anhydride, it forms glucose pentaacetate, thus confirming the presence of 5-hydroxyl group. And last one is if you treat it with a strong oxidizing agent like nitric acid, it is going to form a glucosuccaric acid, which is confirming the presence of the primary hydroxy group. Okay, so this is all about the glucose in this video. So I hope you have understood this much. If there is any doubt, do let me know. And if you like my video, do not forget to like, subscribe and comment on my video. Please click the bell icon for more such videos. Thank you so much.